Oxides of carbon. Carbon forms two stable and important oxides, carbon monoxide or carbon 2 oxide, CO, and carbon dioxide or carbon 4 oxide, CO2. Carbon monoxide is formed when incomplete combustion of gasoline, petrol, and diesel occurs in automobile engines. Carbon dioxide is formed during complete combustion of fuels. Carbon monoxide forms in lower oxygen environments and is very harmful to living organisms, even in small amounts. Carbon monoxide and carbon dioxide are always present in automobile exhaust. Oil furnace heating units in residential settings also produce carbon monoxide during combustion in a less oxygen-rich atmosphere. Traffic congestion, idling vehicles, will cause air pollution and possibly cause a dangerous buildup of carbon monoxide at breathing level. Carbon dioxide is a naturally occurring substance, and it plays an important role in Earth's ecosystem. Its amount has been increasing due to human activities and fossil fuel burning, causing global warming and higher temperatures on the surface of Earth. Carbon monoxide, CO, or carbon 2 oxide. It is formed by incomplete combustion of carbon and carbon-containing fuels. 2C plus O2 produces 2CO, but we're talking about a low oxygen containing environment. It can also be prepared by the reduction of heavy metal oxides with carbon, as shown. In the laboratory, carbon monoxide is prepared by the dehydration of formic acid with concentrated sulfuric acid, H2SO4, at 373 Kelvin. Carbon monoxide is a neutral oxide, colorless and odorless toxic gas. Its toxic nature is due to its ability to combine with hemoglobin to form a stable complex. This carboxyhemoglobin destroys the oxygen carrying capacity of the hemoglobin, leading to death. Carbon monoxide is used for the synthesis of water gas or synthesis gas. It is a mixture of carbon monoxide and hydrogen. It can be produced by passing steam over red-hot coke according to this reaction where we get carbon monoxide and hydrogen. Synthesis gas, a mixture of carbon monoxide and nitrogen, is made by passing air over red-hot coke according to this reaction. So air has a mixture of these two gases, and we end up with carbon monoxide and nitrogen gas. Carbon monoxide is a powerful reducing agent since it can be easily oxidized to carbon dioxide. It reduces metal oxide to the respective metals and is used in metallurgical process. It forms metal carbonyl complexes with transition metals such as nickel and iron, as shown here, where we have these metal complexes with carbon monoxide. They're formed when the metals are heated at high temperature in the presence of carbon monoxide. Metal carbonyls are coordinate covalent compounds in which the carbon of the CO group is directly connected to the metal. The carbon atom uses its electron pair to share with the metal atom to form the bond. Metal carbonyls are used in metallurgical separation processes of metals. Carbon dioxide, CO2, or carbon 4 oxide. Carbon dioxide is prepared by burning carbon, fossil fuels, and other organic compounds in air or oxygen. You can see methane in oxygen to produce carbon dioxide in water. In the lab, it is prepared by the action of acid, so in this case CO2, on a metal carbonate like calcium carbonate to produce calcium chloride, carbon dioxide, and water. On an industrial scale, it is obtained as a byproduct during the manufacture of lime or ethyl alcohol by fermentation. So this fermentation process leads to carbon dioxide in both cases. The physical properties of carbon dioxide are quite different than that of carbon monoxide. Carbon monoxide has a triple bond structure, whereas carbon dioxide has a double bond structure, as shown in these two Lewis dot structures. Carbon monoxide is polar. You can see the dipole in this direction, whereas carbon dioxide is nonpolar due to the symmetric arrangement of the two oxygen atoms. So these two dipoles, when added, result in an overall nonpolar molecule. The carbon-oxygen bond is stronger and shorter in the carbon monoxide compared to the bonds in the carbon dioxide because the electrons are pulled in more tight due to the triple bond. As a result of the structural differences, the physical properties of carbon dioxide are quite different than that of carbon monoxide. You can look at the huge difference in melting point and boiling point, density, the shorter bond length of the triple bond, and a great difference in heat of formation. Carbon dioxide is non-combustible. It is slightly soluble in water, and the solubility increases with pressure. It is used in making soda water or aerated soft drinks. It is acidic in nature. When dissolved in water, it forms carbonic acid and is acidic. The carbonic acid forms two series of salts, bicarbonates and carbonates. When CO2 is passed through lime water, it turns milky due to the formation of carbonate. This test is used for the identification of CO2 gas produced from carbonate salts in qualitative analysis. Carbon dioxide is absorbed by plants in the presence of chlorophyll and sunlight. The reaction is known as photosynthesis and produces glucose and starch in plants. So the reaction shown here, this is photosynthesis, showing the capture of the carbon dioxide by plants to produce glucose and oxygen. In cellular respiration, the reverse process happens in the plant cells, where glucose and oxygen produce carbon dioxide and water. When reacted with liquid ammonia at 450 to 475 Kelvin under pressure, CO2 produces urea, widely used as fertilizer. It is used in fire extinguishers. Solid CO2 is used as a refrigerant, commonly known as dry ice. CO2 is used for the manufacture of washing soda by the Solvay process. A combination of 5% CO2 and 95% oxygen is used for artificial respiration under the name carbogen, and it is used for the purification of sugar.